Welcome everyone! Today we're talking about JavaScript array methods. In this opening part, we're going to first understand what an array is. An array is a versatile data structure that can hold items like numbers, strings, and even objects. Now, let's dive into how we can create arrays in JavaScript and get ready to use them to their full potential. First, let's look at how to create an empty array. This is as simple as it gets. We have declared a variable myArray and assigned it to an empty array. There's nothing inside the square brackets, which indicates that the array currently has no elements. Now let's create an array with some data already in it. In this example, populated array starts off with 3 numbers, 1, 2, and 3. Each number is a separate element in the array. You're not just limited to numbers though. Arrays can contain all sorts of values, and you can even mix types. Here, mixed array contains a string, a number, a boolean, and a null value. JavaScript arrays are flexible enough to handle different data types all at once. But what if you have variables that you want to group together into an array? You can do that too. In this snippet, fruit array is created with the values of the variables x, y, and z. Each variable represents a different fruit name, and they're all grouped together in our array. You may sometimes see arrays created with the new array syntax, but it's generally recommended to use the square bracket notation for simplicity and clarity. Here's an example to highlight the difference. This does the same thing as our earlier example with populated array. However, using new array can be a bit confusing, especially when you pass a single number, which creates an array with that number of empty slots, instead of an array with one element. As you can see, confusing array doesn't contain the number 3. Instead, it's an array with 3 empty slots. This is why the square bracket notation is preferred. Now let's move to the next section, where we'll learn how to access elements within an array. Each element in an array is assigned a specific position, known as an index. Remember, JavaScript array indices start at 0. So the first element is at index 0, the second at index 1, and so on. Take this array of colors, for example. If we want to grab the first color, we simply use square brackets with the index 0, like this. And there you have it. Red is assigned to the variable first color. Easy, right? A quick tip though, don't try to use dot notation with arrays. It won't work and will give you a syntax error. Always use square brackets to access array elements. Now what about the last element? Since JavaScript doesn't support negative indexing like some other languages, we can't do colors. 1. Instead, we use the length of the array -1, like this. Just like that, we've accessed blue, the last color in our array. So what did we learn today? Arrays are 0 indexed, so counting starts from 0. Use square brackets to access array elements. And remember, you can find the last element with the array's length property -1. In the next section, we'll explore how to manipulate the elements within our arrays. In part 2 of our JavaScript Array Essentials series, we're focusing on array manipulation. Let's start with an array that contains the names of some fruits. Our initial array contains 3 fruits: apple, banana, and cherry. Now, we're going to add a new fruit to the end of the array. We'll use the .push method for this. Notice how mango has been added to the end of the array. But what if we want to remove the last element? We can use the .pop method, which removes the last element and returns it. We've now removed mango from the array. Let's add a fruit to the beginning of the array. The .unshift method allows us to do just that. Now strawberry has been added to the front. If we need to remove the first element, we can call .shift, which works like .pop, but for the first element. There goes strawberry. What if we need to insert a fruit in the middle, or replace one? Splice is the method for that. Let's insert kiwi at the second position without removing any item. Let's break down the .splice method arguments step by step. Splice can take 3 parameters here: the start index, the delete count, and the item s to add. The first argument, 1, specifies the start index. Array indices start at 0, so an index of 1 refers to the second position in the array. That's where we want to insert kiwi. The second argument is the delete count, which in this case is 0. This tells .splice how many elements to remove at the specified index. By passing 0, we're indicating that we don't want to remove any elements, just insert kiwi. After the splice operation, you can see that kiwi has been added to the array at the second position, right after apple, without any items being removed. Now you see kiwi right after apple. But let's say we want to replace kiwi with peach. We can use .splice, again, specifying we want to replace one item at index 1. And that's how kiwi gets replaced with peach, but .splice isn't done yet. It can also remove items. Let's remove peach by specifying we want to delete one item at index 1. Now peach is gone. Splice can even be used to add multiple items. Let's add peach and grapes back into the array at once. This is your array after a few rounds of manipulation. With .push, pop, unshift, shift, and .splice, you have a toolkit that can handle most of your array manipulation needs. Welcome to part 3 of our JavaScript array methods series. Today, we're exploring array transformations. Transformation has two types, those that create a new array and those that modify the original array in place. First up, return new array methods. As the name suggests, these methods let you take an existing array and produce a brand new array. The beauty here is that your original array remains untouched, pristine as ever. Here we used map to double each number. We ended up with a new array of doubles, while our original numbers array remained unchanged. On the other hand, modify in place methods are the renovators. They directly alter your original array. Here, reverse turned our array around, and it did so right where it stood. The original array has been updated, and that's the new state of affairs. First up in the methods that return a new array is the map function. Let's take a closer look at how it works. The map method is called on an array and takes a callback function as its argument. Here's the basic syntax. In this syntax, array is the original array. New array is the array that map builds as it processes each element. Callback is the function that map applies to each element of array. Current value is the current element being processed. Index is the index of the current element being processed, and it's optional. Array is the array map was called upon, and it's also optional. Now let's consider the use cases for map. First up, transforming values. Imagine you have an array of numbers, and you want to square them. It's a classic scenario for map. We start with an array called numbers composed of 3 elements, 1, 2, and 3. The map function takes the first element, which is 1, and passes it into the arrow function. Within this function, num is multiplied by itself, so 1 multiplied by 1 equals 1. The result is placed into the new array squared numbers. Moving on to the second element, the map function now takes 2 and again applies the same arrow function. This time, 2 multiplied by 2 equals 4. The result, which is 4, is added to the squared numbers array. In the third iteration, the map function processes the last element, which is 3. Following the same process, 3 multiplied by 3 equals 9, and this 9 is then added to our new array. After the final iteration, our squared numbers array is complete, and it contains the elements 1, 4, and 9, which are the squares of the original elements from the numbers array. Next, let's look at extracting data from an array of objects. A common task in data handling. We start with an array named people. This array contains 3 objects, and each object represents a person with a name and an age. We invoke the map method on our people array. The map method will loop through each object in the array, one by one. With map, we easily pull out the age from each person object, creating a clean list of ages. It's concise and expressive. Moving on, reformatting objects. Sometimes you need to reshape your data to fit your needs. We have an array called products that contains 2 objects. Each object has a name and a price property representing a product. Our goal is to create a new array called formatted products, where each product has a product name and a product price instead of just name and price. After the map method has finished its work, we end up with a new array, formatted products. This array has the same number of elements as the original, but each product object now follows our new format. Lastly, map isn't just for synchronous operations. It can handle asynchronous functions too, but with a little twist. In this scenario, map is used to fire off a series of fetch requests. Each returns a promise, and promise.all is crucial for managing these promises, allowing us to wait for all the data to arrive before proceeding. As we've seen, map is not just a loop. It's a transformation tool, a data extractor, a reformatting assistant, and much more. Let's explore another powerful array method in JavaScript called filter. This method is used to sift through an array and extract elements that meet certain criteria. Imagine you have a basket of apples, and you only want to keep the red apple. You would go through each piece of apple, check if it's red, and if it is, you place it in a new basket. That's essentially what filter does with arrays. Now, let's bring this concept into a coding context with an example. Here we have an array called people, which is a list of objects where each object represents a person with a name and an age. We want to create a new array called adults that only includes the people who are 18 years old or older. On the first iteration, filter examines the first person, Alice, who is 25 years old. The filter function applies a test, checking if Alice's age is 18 or above. Since she is 25, she passes the test and is included in the new adults array. Moving to the second person, Bob, who is 15 years old. Bob's age does not pass our test, as he is under 18. Therefore, he is not added to the adults array. The method continues to Carol, who is 30 years old. Carol passes the age test and is added to the adults array. After the filter method has gone through the entire people array, we are left with a new array, adults, which includes only the people who met our criteria, being 18 years or older. Now, let's explore the reduce method, which is like a multi-tool for processing an array's elements and coming up with a single cumulative value. To see reduce in action, let's look at a coding example. Here we have an array called numbers that contains 3 numeric values, 1, 2, 3. Our goal is to calculate the sum of all the numbers in the array. We call the reduce method on our numbers array. This method will process each number in sequence and accumulate a result. Reduce starts with an initial value for the accumulator, which in this case is 0, as provided in the second argument of the reduce call. On the first iteration, reduce combines the accumulator's current value 0 with the first number in the array 1. The function adds them up, resulting in a new accumulator value of 1. Moving to the second number 2, reduce adds this to the current accumulator value 1. The method continues with the third number 3, adding it to the accumulator's value 3. After processing all array elements, reduce has effectively summed them up, and the single resulting value is stored in sum. Now let's turn our attention to reduce write, a variant of the reduce method. This method works similarly to reduce, but with one key difference. It processes the array elements from right to left, starting with the last element and moving towards the first. Let's see how reduce write is used with an example. After reduce write has visited each element in reverse order, we're left with a single string that is the result of concatenating all the array's elements from right to left. Next up is flat depth. It's a fusion of map and a depth 1 flat. It first applies a mapping function to each element of the array and then flattens the result into a new array. In this first use case, we begin with an array of arrays. Our goal is to double each number and then flatten the result into a single array. The flat map method maps each subarray, doubles its elements, and then flattens the results. The output is 2, 4, 6, 8, a flattened array with each number doubled. In our second use case, the array contains both numbers and subarrays. We want to create a flat array without any nesting. The flat map ensures that each element, whether it's an array or not, becomes part of a single flat array. The result is 1, 2, 3, 4, 5, 6, a single-level array composed of all the individual values from the mixed structure. In the third use case, we have an array that includes empty slots, which we want to remove. By mapping each element and filtering out the undefined values, converting them into empty arrays, FlatMap effectively removes the holes. The final output is 1, 2, 4, 5, a compact array without any gaps. Keep in mind that FlatMap only flattens one level deep. Lastly, we come to slice. This method is like a precision knife for arrays, allowing you to cut a portion of the array without affecting the original array. It creates a shallow copy of elements from the original array, defined by a given start and end argument. In our first use case, we have an array of fruit names. We want to get the first 2 fruits. By calling slice02, we tell JavaScript to start at index 0 and stop before index 2, effectively slicing the first two elements. The output is apple and banana, a new array containing just the sliced elements. In the second use case, we want to extract a piece from the middle of our fruit array, specifically from the second to the fourth fruit. Calling slice14 starts the slice at index 1 and slices up to, but not including, index 4. The result is banana, cherry, and date, a new array with the fruits from the middle of the original array. For our third use case, we aim to slice the array to get the last two fruits. By using a negative index, slice-2 starts the slice two elements from the end of the array. The output is date and elderberry, which includes the last two elements from fruits. In the fourth use case, we want to make a copy of the entire fruits array. By not specifying any start or end index, slice defaults to slicing the whole array. The result is a new array apple, banana, cherry, date, and elderberry that is a shallow copy of the original. These examples show that slice is a non-destructive method, meaning that the original array remains unchanged after the method is applied. Now that we've examined methods that don't alter the original array, it's time to explore methods that do modify the array in place. Let's start with first method, which is a sort method. This method rearranges the elements of an array in a given order, typically in ascending or descending order, and it does so by modifying the original array. When sort is applied to an array of strings without any additional arguments, it sorts the strings alphabetically by default. Here, fruits.sort organizes the fruits in alphabetical order, resulting in apple, banana, cherry. The original fruits array has been sorted in place and is now in this new order. Sorting an array of numbers is not as straightforward because sort converts the numbers to strings and compares their Unicode values by default. To sort numerically, a compare function must be provided. In our example, sort function sorts the numbers in ascending order. The result is 3, 7, 10, 50, where the original numbers array has been modified to reflect this order. For more complex data like arrays of objects, sort requires a compare function that knows how to interpret the data. In this example, items.sort function sorts the items based on their price property. Remember that sort always modifies the original array, so if you need to preserve the original order, you should first create a copy of the array and sort the copy. The next one is reverse method. This function inverts the order of the elements within the array, flipping it like a pancake so that the first element becomes the last and the last becomes the first. We have number array here. When reverse is used on our numbers array, the array is transformed in place to 5, 4, 3, 2, 1. The original numbers array is now in reverse order, with the last element 5 moving to the first position and the first element 1 moving to the last. The final method in our exploration of array modification methods is fill. This method allows us to fill all the elements in an array with a static value from a start index to an end index. Here, we create an array of 5 empty slots with new array 5, and then we fill it with 0 using array.fill0. The original array has been updated in place to this new uniform value. Now move to the use case number 2. In this example, numbers.fill fills the numbers array with x, starting from index 2. Keep in mind that fill modifies the array in place, and there's no undo button. Once an array is filled, the previous values are overwritten. With this, we conclude our journey through the array methods that modify the original array in place. Each method serves a unique purpose, allowing us to manipulate and control our data structures effectively. Today, we're diving into the world of arrays, specifically how to search through them using various methods. Whether you're a complete beginner or looking to refresh your skills, this video is for you. Let's code and make searching arrays a breeze. First up is the indexOf method. Imagine you have a lineup of your favorite fruits, but you're particularly fond of apples. How do you find where the apple is? Just ask indexOf. We call on the indexOf method, a super handy tool that helps us find the position of an item in an array. Let's start at the very beginning, the first item in our list. Nope, that's a banana. Let's move on. And there we have it, folks. Our first apple is sitting right here in the second slot, but remember, we count from 0. Just like that, indexOf checks our array, and when it finds the first match, It tells us the position. For our apple, it's 1. Now, what if you want to find the last apple in our fruit lineup? That's a job for last index of. By calling fruits.lastIndexOf apple, we're asking JavaScript to find the last occurrence of apple in our array. And voila! It tells us that the last apple is at index 3, the 4th position since we start counting from 0. Moving on to find. The find method in JavaScript is like a tool that helps you find the first thing in a list that matches what you're looking for. If it finds something that matches, it gives you that thing. If it doesn't find anything, it gives you nothing, which in programming we call undefined. Let's see it in action with our lineup of numbers here: 4, 9, 16, and 25. Let's say we're on a mission to find the first number greater than 10. Our find method takes a test function. Here, it's checking if an element is greater than 10. First, you compare it with 4. But 4 is not greater than 10, so you continue. Next, you compare it with 9. Just like 4, 9 is also not greater than 10. So, you move on, then you come to 16. Now, 16 is greater than 10. That's it! You found the first number in the line that is greater than 10. The next one is find index, which find the index of an item based on a specific condition. So let's use our line of numbers again: 4, 9, 16, and 25. We want to find the position of the first number that is greater than 10. We start with the first number, which is 4. This is not greater than 10, so we move on. Next up is 9. This is at position 1. But 9 is still not greater than 10, so we keep looking. Then we reach 16. This number is at position 2 in our line. Aha! Since 16 is greater than 10, we've found our number. But instead of giving us 16, find index tells us that the number we're looking for is at position 2. The find last method in JavaScript works similarly to find, but instead of starting from the beginning of the array, it starts from the end and moves backwards. It's used to find the last item in an array that meets a certain condition. Let's say you have an array of numbers like this: 4, 9, 16, 25. You want to find the last number in the array that is greater than 10. Here's what you would do. It looks at 25 first. Is 25 greater than 10? Yes, it is. So there's no need to continue because we've found our number. The result is that last item will be equal to 25 because that's the last number in the array that is greater than 10. If there were no numbers greater than 10, find last would give you undefined. The find last index method is like find index. But instead of looking from the start of the array to find where a certain item is, it starts from the end and goes backwards. It tells you the position of the last item that meets your condition. Let's use the array 4, 9, 16, 25 and look for the last number that is greater than 10. Here's how you use find last index. The method starts by looking at the last number, which is 25. Is 25 greater than 10? Yes, it is. So, it doesn't need to check any other numbers. The result is that last item index will be 3, because 25 is the last number greater than 10 in the array, and its position is 3. But what if you're just checking to see if your fruit basket has mangoes? Includes is perfect for a quick yes or no answer. The includes method is used to check if a certain item is in a list, which in programming is called an array. It gives you a simple yes or no answer. In programming terms, it returns true if the item is there, and false if it's not. Let's look at an example with a list of fruits: banana, apple, mango, apple. If you want to know if apple is in the list, you would use the includes method like this. First item is apple. So move on to the next one. Since apple is indeed in the list of fruits, has apple will be true. And there you have it, 7 methods to help you search through arrays like a pro. Don't forget to practice what you've learned. Hands-on experience is the best way to get these methods down. Thanks for watching. If you liked the video, hit that thumbs up and subscribe for more. Tap the bell to get notifications. Check out other videos on the channel, and I'll see you in the next one. Take care.